So in this video we're going to take a look at the reverse engineering tools for organic shapes. This is in InStep Studio version 3.1, which is the current release. So for this section we only have a couple of tools available, so we're just going to start with an example. We're going to go to import, we're going to open a shape, and we have one from a previous tutorial. This is a relatively large size model, so it's about 150,000 features. Often 3D scans particularly will come in a lot larger, but if you take a look at the body's video, we have a way of reducing those facets, especially for very dense models, down to more reasonable size. I'm not saying the application can't handle a lot more. 1 million, 2 million facets is possible, but a lot of these steps will take a lot longer. So what I would recommend is that you start with whatever model you're trying to work with, and especially if it's high organic detail and there's a lot of facets defining small sections, that you maybe consider reducing those down to something more reasonable first. Work with that and see if the result is acceptable before you try and do it with a very high facet count model. That will often reduce processing times quite a bit. So what we're going to do here is we're going to switch over to the reverse engineering section, and we are going to look at both the automatic surfacing and the manual patching tool. For these tools we also have some specific settings that we're going to cover in just a little bit of detail. There's not as many settings specific to these tools as there are for the overall application. The application settings are here. These are general settings, and the ones here are specific to the reverse engineering, specifically organic tools sections. So let's take a look at the automatic surfacing option. The automatic option tries to take the entirety of the body and first wraps it in a second level mesh that's a lot coarser than the original, and then within that new mesh it tries to generate NURBS surfaces. Now NURBS surfaces, which stands for non-uniform rational B-spline, they require 4 corners, exactly 4. The application can to some extent do a format of that that looks like it's only triangular, but usually one of the 4 corners then lies almost exactly on the edge. Generally that should be avoided. It should be as square looking as possible. So how does that work here? The application has 3 sections to this tool. We have the definition section, which you can generally stay away from, especially if you're only working with one body. You don't have to select an individual body to operate on. If you want to generate the seed mesh externally, you can actually directly import and work from that. You can also clear the preview, and there's some advanced features here which are essentially the same as you'll find up here. Now the seed mesh itself is generated here. The patch count is the target number of patches that you want to generate. The application will take that under consideration and try and get very close to that number. Sometimes it will be just a little bit more, usually just a little bit less. We also have different methods by which the seed mesh can be generated. By default, the aligned method is selected, and we'll look at these 3 in details. The aligned is very robust, but in some cases it won't work and we have to fall back to either sampling or the split approach. This slider here just changes the patch count, and it starts off with a function that takes the original data into consideration. I like to modify this quite a bit as I'm going along, and you'll often start with one number, review the results before working through the data, and then deciding whether or not you want to add more or less. The curve sample point should maybe be explained in some detail. When the patches are generated in a preview level, you will see what essentially looks like a quadrilateral mesh being overlaid over the data. The number of sample points is how many points along each of those edges are being used in order to generate the NURBS surfaces. You can increase this. I recommend you start low and then slowly work up, and you may have to go through the entire process several times to find what works well. 4 is a good starting point. I recommend you don't go above 10. Above 10, the algorithm starts getting very involved in terms of how to calculate the NURBS curves that actually end up going through there. Understand when you double this, you actually the number is 2 squared, so times 2 means actually times 4 in terms of the algorithm's complexity. Now, lastly, crease angles. These apply to some of the algorithms more than others. If you set a crease angle, it will try and align the mesh with that, but it's not guaranteed to do so. Down here we also have the approximate surface option. So what that'll do, and this is new for version 3.1. Version 3.0 didn't have that option. So version 3.1, when you have this turned on and you generate a preview, it will show you the result as if it were using the NURBS data, but displayed as facets, as a triangular mesh again. So it is an approximation. It's not the exact thing. You only get that once you export. Even once you go through this process and you export it to, or you convert it to a NURBS body, that is still an approximation of what the underlying NURBS will be. That is only generated during the export phase. So let's go ahead and look at this. So we have 150,000-ish features, and let's start with, say, 2,000 patches. We're going to keep the aligned method, we're going to keep the sample points and curve, we're going to hit generate preview, and this tool will briefly show up, which is an external application that calculates the patches for us. Now, this is the result of that. If we turn edges on, we can kind of see the underlying representation of this. But what we should point out is that overall this looks very good. Now, we have a few areas where things start getting a little collapsed, a little messy, and that's here in the neck area. That's difficult to avoid just because of how the data is aligned. If we turn this back off, you can see the original data was actually very much already collapsed in this area. So it's going to be very hard not to have that happen. But with this turned on, we can see that the original doesn't actually differ much from this body. There is I do have the original file, which is more detailed than this. This is for the example. It's reduced already to make things run a little smoother. So anyway, we see that the mesh is well aligned, hence the name. It tries to follow the overall, it's actually called energy lines in this case, but it tries to follow the overall flow of the surface. If instead we have a shape where we switch to the sampling, first of all, there's a couple extra options that show up. Generally, I avoid the adapt curvature, even though there is some benefit in using that. But if we use just the same configuration as we just did and we generate a preview, we'll say a run through it and we end up with this mesh, which does look very different. Essentially what the sampling approach does, it tries to use the original mesh as much as possible and to generate a mesh from that. So it will end up having a quadrilateral mesh, which is what we see here, what I said the NURBS actually needs. It's a quadrilateral mesh that has more detail in areas where the original mesh had more details and fewer or coarser mesh elements where the original one wasn't quite as detailed. If there are issues with this mesh, so for example concave elements being detected, an extra checkbox shows up down here that allows us to highlight those. And really what it'll do is it'll generate individual points where a concave element has been detected or where it's likely. They're not always easy to see, so if that does show up, it's generally just an indicator that at least one of the surfaces won't be well behaved. What's interesting is we can export this mesh directly as an OBJ file. So if we click on this, it'll just bring up and say, hey, where do you want to save that mesh to? And we can save it as a separate mesh and then manually fine-tune certain things in an external editor such as Blender or other applications that can work with OBJ files. It should be pointed out that the resultant mesh will be a quadrilateral based mesh, as is this, and if at all possible the mesh should be a quadrilateral mesh when you go back to importing it. So this is the reverse, then you import that mesh back in here and it replaces the original mesh. Now one thing to point out there is when the mesh is being imported, it'll check if it's a triangular or a quadrilateral mesh, and if it's a triangular mesh, it'll try and convert it back to quadrilateral elements, because again, NURBS requires a quadrilateral approach, but also it'll project the vertices of that new mesh onto this source body. So we could take this to some extremes and actually import a mesh that represents a completely different body, and it'll try and project the vertices onto this one. Obviously, if those points are too far off, the results become quite unpredictable. So only do that with with a certain level of inaccuracies in mind there. But yeah, so we have the option of exporting the mesh, externally modifying, tweaking little things like this element doesn't look very good, so maybe you'd want to push this over a little bit. Things like that can be done in an external application. This application just doesn't have that level of edit tools incorporated yet. It may come at a later point, that's to be determined. We also do have a few very basic tools we can smooth and sharpen this. So I think this is an area where you see that effect taking place. So what I'm going to do is I'm going to turn on our rotate indicator with Alt and R, and then I'm going to select this mesh here. There we go, and it sets this little point here, and that becomes now our new rotate center. That's also an easy way of just keeping track of a location as things change. So I'm going to go in and I'm going to hit the smooth mesh option, and it'll go through and it'll incrementally smooth the mesh. Now in this case we don't really see anything because the mesh is already well smooth. Maybe down here we can do that again and see about any other changes. Yeah, so in this case there's not much happening. The algorithm has built in that when it goes through and does this, the application will smooth it. In the settings options, we actually have the ability of setting how many smoothing iterations we apply and what kind of factor that's done to. So if we set this to 0, then the manual option will have more effect. We can also do the reverse, which is going to try and move some of these vertices closer to sharp edges. So you see in this case there's a lot more effect because the application doesn't try and sharpen it. But we've seen some of these try and move a little bit closer to there. Not always ideal. We probably don't want to do that too much just because it's going to try and modify the mesh too much. Any manual changes, like I said, I recommend you export it and then you import it again. If we do an adapt curvature option in this, we can take a look at what that looks like. We'll see it actually does it does change the mesh a little bit, and it tries to follow the overall gradients of the mesh a little bit more. So inherently what it tries to do, it tries to get a little bit close to this aligned mesh with an internal set of capabilities. It will never get there, that's not the point of it, but it does try and move stuff around a little bit. Now, like I said, sometimes the mesh doesn't come out correct, so this would be a case here where you probably want to go in and change things a little bit. We can also increase this, so around 2000, maybe 3000 is a better option. And here we see this actually does resolve it. We do still have a lot fewer surfaces than the original, but it still very much approximates the original surfaces. What I should point out is most CAD applications are okay until you hit about 10,000 patches, and after that it slows down. If you hit 20,000, you're starting to get into the territory where CAD applications actually struggle to import that many patches. Anything below 10, I would say, is fair game. 10 to 20 is kind of challenging, and above that, it's hit and miss depending on the CAD application. Some are better than others. Now, also, and in this case, by the way, it does say there's a problematic corner, so we can turn that on, and it puts a marker up here. So if we zoom in, we can kind of see, now I'll turn the facets off. We're going to place the rotate marker there, and you can see how this element is highly distorted. So very likely that even though the export might include this element, and it's not always guaranteed that it can resolve these issues, is a good chance that the CAD application will struggle to import that correctly or tie them together into a solid body. So it's just one thing to keep in mind. Lastly, we're going to take a look at the split option. Now the split option is a last resort option. So if the aligned option and the sampling option don't work, the split option is all but guaranteed to result in a mesh. But the algorithm that it uses to get there is not guaranteed to give you good shape. So let's take a look at what it looks like here. So this one's actually not too bad. It has resulted in decent level of detail without getting too complicated in some places, but we do still have some problematic sections, and again it's in this eye area. So ways that we can resolve that is we can go with more patches. So let's use 10,000 as an example, and we can still keep that split option. And now we can actually see that this section is definitely better resolved. So even though some of them are still not perfect, this section is fine. And also keep in mind what you can do once you've converted this to CAD. You can go in and change these up again because it becomes an editable body. If we encounter situations like that, sometimes it's just better to go back to previous methods and increase those numbers. This is very much hit and miss, and experience will start guiding you towards what's the best approach with some of these. So this actually looks pretty good. Overall, good layout of the meshes. It's definitely more detailed than other cases. And by the way, I don't know if you've noticed this, but we had 10,000, we clicked preview, and when he did that, it automatically switched over to the convert tab. So it's basically saying it passes all the internal checks, it looks like it's going to be a good outcome, you just want to go ahead and convert. You can always come back and change your seed mesh. We may want to go back and do, you know, slightly larger than before, but not as many as we had there with the aligned method, and see what that gives us. The whole point of this is to iterate through the seed mesh to come up with something that inherently looks like a a well-defined mesh. And this is probably, you know, if I were to make this body as part of a project or something like that, this is probably the level of detail that I'd be looking for. It's relatively coarse in the sense that it's you know 1/30th of what the original is, but it gives us all the detail. And like I said, the preview that we have, the approximate surface, this is actually the level of detail that the NURBS will capture. We can go in and change this, so let's do that and double that. And like I said, this will take a little bit longer to convert. And once the pop-up disappears, it basically means the external application has done its part and it's moving back into importing the data from that application and running conversion tools to align the data onto the existing body and to also sample the sets from it. So what we should see here in a second, once it finishes loading, is that we get a lot more detail in these sections. Okay, so yeah, we can see there's more individual facets within these. And that's one benefit of having this flat shaded section. We can actually see individual parts in here. So here you'll notice you have 8, like we defined, we have 8 sample points internal to these divisions. We can roughly see where these divisions are. So if we look at this line here, I'm going to place the marker there, and then we're going to have another section here. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9 patches, which means that we have 1, 2, 3, 4, 5, 6, 7, 8 points internal to this actual line. So that's how this number is meant to be interpreted. We have this many divisions along each section. If we make this quite coarse, so let's do 3, we'll see 1, 2, 3 points inside of this section right here. So there you go. 1, 2, 3. And that's where having a larger number of sample points will give you a slightly smoother transition, but it comes at the cost of a larger file. Now, if the patch count is low, we can afford to have more sample points. But like I said, I strongly caution against going too high on these, because the mathematics behind this actually gets very CPU intensive once you go above about 8 or 10. So keep that in mind for this. Now let's take this through. I'm going to set it back to 8. We're going to update the preview again. And then we're actually going to go through and we're going to export this as a body to see what the result looks like. So here we have the export, or the align method complete. We see it says 8 points internally, and the application is switched over to the convert section of this tool, and it really gives us the option of what we want to do with this now that we're ready to convert this body. I do recommend that generally you delete the original body, otherwise it'll create 2 bodies essentially overlapping each other. And my experience has been that it's often then ends up be that you export both, or that it's not clear which is which. So I recommend you keep this on the NURBS order. It gives you linear, quadratic, cubic, and quintic. Cubic generally is the one I recommend. It's a good balance between smoothness of the curves and efficiency. Quintic is an option. I've seen too many exports fail because people think, the higher the better. And quadratic, even though it still gives you a smooth continuity between the knot points on that curve, it's almost a little bit too simplistic. So cubic is what I recommend. If you want to reduce file size a little bit, quadratic. I would generally stay away from linear in quintic, is I guess the takeaway. With that said, if you click convert, the original data will be used to generate the application's internal NURBS surfaces, which is a slightly different data set. It holds more of that actually converted data within it. And once that is done and the progress bar will flicker through it as the individual surfaces get completed, it gives us it'll show here success, and it'll give us the actual number of surfaces generated. Like I said, this number will often be just a little bit different from the target number, so keep that in mind. It's not always exactly the same, and there's a number of reasons why that may be the case. So once we have that, we can close out of this. It'll quickly update the display, and then this is what we're left with. Now you might say, well, that's what we started with, so what's going on? The reality is this isn't what we started with. This is actual NURBS representation of the data. If we turn on the edge modes, we can now see that these patches are in fact what we define as the seed surfaces. Yes, there is just a hint of that non-smoothness, but that's really the transition between individual patches, because this is defined, if you're familiar with NURB patches, this is a G0 continuity. So it means the edges line up, but there's no smooth transition from one to the other. And that is actually consciously defined that way because we may have scenarios like on the pedestal here where if it gets too coarse, we don't want this to be rounded off. We actually do want a relatively sharp edge. Now, this is, only partially sharp. But again, the point of this conversion is to generate NURBS patches per our definition, not necessarily to generate a completely smooth surface. So that being said, this would be our NURBS body, and all we have left to do is go ahead and export it to a boundary representation model. So again, this is not available as a faceted or a slice data because we've converted this fully to a BREP model. So the only options we have are either STEP or IGES. And IGES is a new export option that we have with version 3.1. The application did undergo a complete rewrite of the export functions, and something we're going to touch on during the video where we talk about the export tools. But we can click on Step Export, we can pick a file, and I'm just going to go ahead and call it this, and we're going to save it, and this will take a minute or two to export. The update shows this here. To be mentioned maybe is that this progress covers the actual conversion of the individual patches, so these 4,857 NURBS patches, into a representation that's used in the export tool. So I'm going to let this run, and then we're going to look at the output. So this finished, so the export is done. It does take a little extra time, so the progress bar will fill up, and then when it looks like it's done, it seems to stop. So what's actually happening internally is the progress bar shows all the facet or the features being written to file, and then when that's done is those features get sewn together into a surface, and some basic healing methods applied because often there's small discontinuities or issues like that. So what to look out for is on the status window over here, it'll initially not say anything, and then it'll say writing to file. That's the time when the application actually starts the true saving to the file process. So in this case, this took about 3 minutes to save. So we're going to take a look at the result of this in SolidWorks. This is SolidWorks 2024. And we're just going to go ahead and load that file and take a look at what SolidWorks tells us in terms of the quality of the output. So once import completes, which in this case can take a few minutes, this is a 98 megabyte file, we get asked if we want to run import diagnostics and all that. So we're going to go ahead and click yes. And what comes up is that there are a few faces, so fair number of faces actually, that it has some kind of issue with, and that is somewhat to be expected. Some files work perfectly fine, others have issues. It is very difficult to prevent that completely. Every effort's been made to try and do that, but in some cases you just have to go in and manually fix some of these. I have found that generally changing things such as the number of sample points to a lower number and using quadratic rather than cubic NURBS surfaces can help. It very much depends on the scenario. A lot of these errors will also show up in one application but not another, so that's another thing to keep in mind. But generally the application does allow you to bring in most, if not all, surfaces, and generally, looking at this, there's 6 gaps, so maybe fixing these gaps would allow the whole thing to be healed. Obviously on this side there's something that's going wrong. Generally I recommend going through those processes and seeing what values make sense, starting with a coarse model, loading that. It might be that one model works because it's coarser, or one model might work that works because it's more refined. So that's just something to keep in mind here. Now, going back to this, what we want to close out with the manual patching option. So I'm going to go back, I'm going to reload this body, and now we're going to go straight back to reverse engineering. And the manual patching is intended for scenarios where you have a large data set. So let's say something as big as this, or bigger usually from scanned data, and you're really only interested in a small section. So for example, what I've personally used quite a bit is if you have scanned data of an entire assembly, but you just want to create something that mates with certain features of an existing assembly. So for that case, you don't need to convert the entire body. You can just use the manual patching. And in this case, yeah. So clicking that brings up the manual surfacing option, and it just shows us the body. That's just the name of it here. And nothing else is given right now. So what we do is we do the create option, and it brings up manual NURBS seed. It's essentially asking us to define the point of those quadrilaterals, and we can just go in and start point 1, and you see there's a little blue dot under the mouse, and let's say we just click here, it switches over to point 2, click here, click here, click here. And once we have those 4 points, we can tell it, go ahead and apply that. And if we turn off facet mode, we can actually see where that would be. Obviously, we're more interested in the points right now, but those 4 points now define a separate NURBS patch. We can continue that process, so we're back at point 1. and then we can come in and pick extra points. We can go back in, we can create new points, and then from that grow patches that way. If we get close enough to an existing point, it will snap to it. So with that, we can go back and we can turn facets off and we can see this representation, or also with facets on, we can see these where the patches will be. We can also go down into the visibility and turn off body 0, so the actual underlying body, which if we click on it gets highlighted. Click on that, update, and then we see essentially what the NURBS surfaces will be. If we like this, exit out of it, and just like before, we can go to export and then export all of this. Now note, with this loaded still, everything will be exported if we export from here. So what we do here is we actually go to bodies, pick this body, and then delete, so that we're left with just the NURBS. And we'll go ahead and export that, and we'll call this partial. And obviously this is a lot quicker because it's just these full surfaces. So if we go back in here, we're going to X out of this. Obviously it doesn't like the data because it's not a closed surface in any kind, but we do have the actual patches that we can work from. So we could use this and thicken this in SolidWorks, or do whatever else we want to do with these patches as a way to use that as a reference of the original. So that's it as far as the reverse engineering for the organic shapes is concerned. In the next tutorial, we're going to take a look at the slice data, and then in a later one, we're going to look at the relief data as well, and that will close out our reverse engineering options.